Okay, well, thank you everyone for coming back from lunch so promptly, including the people coming in the door. So we're now moving to the next phase of our day, and really the whole point of this session is to talk about how we build our community around modelling. And as I've been going around the country, one of the nodes I visited asked me, look, who actually does this well? Is there any examples that do this well? And what can we learn off them? And the answer is that the people who do this well, or in my view, the people who do this best of all is NCAR. And so for the next talk, we've invited Gokhan Danabasoglu to address us. Gokhan's a chief scientist on CESM. He's been working on the coupled model and the ocean model for many years now. And I think I mean it when I say that I think NCAR does a fantastic job of bringing the community along with them and forging a community of climate and weather modelers. So with no further ado, I'm going to hand over to Gokhan to tell us a bit about the community engagement model they use with CESM. So take it away, Gokhan, and if there's anything we need from you, we will stop you. So.
Okay, thank you very much, Andy. Thank you for your kind words, and good afternoon, everybody. I'm actually right now on vacation in Turkey, so it's 6 a.m. here. So as Andy indicated, I was requested to talk about community engagement aspects, how CESM engages community both for model development purposes and also for analysis of the model simulations and getting community collaborate with us in a two-way interaction. So what I was going to try to do here is that maybe talk 15 to 20 minutes or so, trying to cover as many aspects of our community engagement sort of efforts. And then hopefully we'll have about 10 minutes at the end for your questions. So right from the beginning, I should mention that involving community is quite a bit of effort. And we have several aspects. And I thought that I would start with the governance aspect of the community Earth system model. We have been doing coupled climate modeling and for about the last 30 years or so. And our community efforts, engagement of the community with our coupled system became more of an effort perhaps 25 years ago. In other words, 5 years into our fully coupled system efforts. And what I'm showing here is a schematic of our governance structure. And I think community right now is built into our governance structure right from the beginning. CESM has 12 working groups, and these include actual model development working groups, such as for the atmospheric model, ocean model. The sea ice model is embedded in the polar climate working group. We have the land ice modeling working group and land model working group. In addition to that, we have the biogeochemistry and whole atmosphere that's going all the way to the top of the, well, to stratosphere levels. We have a software engineering working group. And then we do also have, in addition to model development working groups, we have model application working groups, such as the paleoclimate working group, climate variability and change working group, and Earth system prediction working group. We are also recently thinking of forming a working group on environmental or climate justice, but this is still in its early stages. Above all these working groups, we have the CESM Scientific Steering Committee, and at the top of all of these, we have an advisory board, CESM Advisory Board. We refer to it simply as CAB. So I think the fundamental aspect of this governance structure is the presence of working groups. Actual work on various aspects of CESM gets done in these working groups. And these working groups consist of scientists, researchers, programmers, graduate students or early career scientists who come together to work on topics on which they share common interests. Each working group has 2 to 3 co-chairs, and at least one of these co-chairs is from NCAR, that's internal to NCAR, and then the second co-chair or one of the other co-chairs is at least one of them is external, meaning that they come from either a university, either from the university community, or they can be coming from a national lab. They are usually from the United States. Each working group ideally has one science and one software engineer community liaison. And this is extremely important especially for modeling groups or modeling working groups, because both either the science liaison or the software engineering liaison actually acts as a communicator with the community between the sort of the NCAR folks and the external folks. And one issue here is that I said ideally, because it is really difficult to get funding for all the 12 working groups to have at least one science and one software engineering community liaison. What we end up doing is that these end up not being full-time jobs, but at least we try to get some funding for half FTE, that's half full-time employee position for these effort for these positions. So if engagement with community is always a two-way street, and we want to make sure that we get something from the community, but also community gets something from CESM. So they have a say at the table. Initial pitches for ideas, science projects occur at the working group meetings. After discussions, and I would say sometimes really extensive discussions at the working group meetings with buy-in of the broader working group members, these pitched ideas are slated to be pursued, and interest level, and of course, funding and personnel challenges are considered during prioritization that come from a working group. If these ideas only concern a particular working group, and if they don't necessarily directly impact another component model, then the prioritization can occur within that particular working group. However, if a pitched idea is broader than a working group, if it impacts the other working groups, if it's cutting across multiple working groups, then those discussions have to happen at the steering committee level. And then after those discussions, after those pitches at that level, then they get essentially prioritized by the steering committee, scientific steering committee. So the second aspect of the CSN governance is the scientific steering committee. It is the deciding body, in a sense, in terms of scientific priorities for CESM. It provides scientific leadership for the CSM project, including oversight of activities of working groups, coordination of model experiments, decision-making on model definition. In other words, when I say model definition here, what I mean is the configuration of the configurations of the model and various development aspects. Whoever is the CSM chief scientist is automatically the chair of this scientific steering committee. I put down our current membership here, and my purpose here is to stress that, as you can see here, with the exception of Jean-Francois Lamarck, who is the director of our lab, all the other members come from the community. So we have, I believe, 12 members. I'm one of them, and Jean-Francois is the other one, and the remaining 10 actual members are all from the community. And we do also have ex officio members, which one of them is our program director from National Science Foundation. Whoever is the CSM chief or CSM lead software engineer, she has in this case, Mariana has a membership here as ex officio, and we have representation from our also computational and infrastructure laboratory. This group usually meets 3 to 4 times per year. Depending upon the level of effort needed, or if something is really trivial to decide, in most circumstances, that's usually the case, I have the authority from SSC to essentially run day-to-day operations of CESM. But if there is something big, then I need, then I seek guidance and advice essentially from SSC. Then the final part of the governance is the advisory board. It serves as an advisory board not only for the CESM Scientific Steering Committee, but also for the NSF Program Director, NCAR Director, and UCAR President. So, I mean, UCAR is the umbrella institution. It stands for the University Corporation for Atmospheric Research, and it oversees NCAR's activities. So this committee is responsible essentially for providing advisory role for all of these entities listed here. Membership in the CAD comes from the university faculty and staff members of other national laboratories, also from scientists from foreign universities, laboratories, and centers. And this is representing here our current members of the advisory board, and they're all external to NCAR. And again, ex officio members include myself, CGD director, NCAR director, UCAR president, and NSF program director. So with that, so that's sort of the governance structure, and the idea was to sort of highlight that we have pretty much a lot of community membership and community engagement in our governance structure already built in. Another effort, or another separate area in a sense, for us to engage community is our annual CSM workshops, as well as winter working group meetings. So once a year, and it was just last week for us, we have the CSM annual workshop. When we have the meetings in person, we get of the order of 300 to 400 in-person attendees. But over the last 3 years, and unfortunately the last one was a virtual one too, our attendance actually went up quite significantly. We had a total of more than, well, we had more than 700 people registered for the workshop, and they pretty much showed up in various working groups. In these or working group meetings, annual CSM workshops consist of sort of plenary sessions, and each working group, of all the working groups that I listed, 12 of them have about 3-hour or 4-hour sessions during the 3.5-day meeting. Most of the detailed sort of exchange with the community and NCAR folks occur during winter working group meetings. Each working group during these meetings usually has about 1 to maybe 2 days, and they discuss many ideas, model development efforts in really great detail. And those are the actually meetings, things get prioritized. And then they bubble up to the surface if there's quite a bit of interest from the broader working group membership. And model development efforts that have those buy-ins from the community, they get prioritized and they start to get implemented. I mean, of course, funding issues aside, and we need to also allocate the proper personnel for that effort, they start to get done during those winter working group meetings. Another major effort that we have is our tutorials. Every year we have annual tutorials. They last for about 1 week. In the morning sessions, we have lectures as to how to use the model, as well as what each model component contains. Their sort of how to set the, for example, what parameterizations that are being used in each component, and what physics they are included. All of those are discussed in the morning lectures, and in the afternoon we have hands-on modeling, how to set up we provide hands-on experience as to how to set up the model, how to run the model, how to change the scripts, how to change something within the model, and also how to analyze the model simulations. So those are the afternoon sessions. Those are the sort of long tutorials. In addition to those tutorials, we have started arranging for half-day to one-day tutorials at AMS or AGU meetings. And these ones have been very popular as well. These don't necessarily involve hands-on components. They essentially mostly involve lectures and how to set up or change the scripts. The annual tutorials are limited to 80 people, and AMS and AGU meeting tutorials, well, they depend on demand, but we generally get about 50 to 100 early career scientists or graduate students. These are, I should say, are targeting primarily early users of the CSM model. And of course, what we call CSM distant learning courses, all of these tutorials are available online. And if people are interested in learning how to run CSM and how to use the model, they can do so simply by going to our websites and downloading these tutorials. And all of these presentations are also recorded and available via YouTube. Of course, you can have all the community engagement, and you can try to bring as many community members as possible. But in order to enable such community interaction, you must have a coupled system or a coupled model that can support a range of climate science goals through a single model code base. And this is quite important for CESM, because by providing many features, we can attract many members of the community to come and use CESM for their research purposes. I just listed a few bullet points here. I mean, by default, of course, all component models can be active, but we also have component models can be used also what we call data models. So for example, one can run AMIP type of simulation within the fully coupled framework. We can run ice-ocean coupled simulations, so-called core simulations or OMIP simulations, again, within a single modeling framework within CESM. So many of these configurations are available out of the box, either as what we call functional releases or scientifically validated releases. We have idealized configurations such as Aqua Planet. We have options for at least 3 atmospheric dynamical cores. We can run the entire system using a slab ocean model or a pencil ocean model. There are numerous choices available within each component model regarding their parameterizations. And pretty much we have lots of increasing numbers of supported component sets and configurations available to the community. Another important part for CESM is to make sure that our model configuration or configurations can run on a multitude of platforms. For example, the CSM model can run on a simple desktop, and these can be, such model configurations can be used as a single column model in coarse resolution applications. And for example, in one-dimensional simulations, they can be used to, for example, develop vertical mixing schemes for the ocean model or for the atmospheric model. CSM can run on small clusters in low resolution applications, and these can be used for example, paleoclimate, long paleoclimate simulations, or they can be used by a sort of simple, on a simple system by a university, single PI research purposes. And of course, at the other end, we have what we call medium or high resolution or ultra high resolutions of CSM available. They can be run on various high HPC systems, and application areas could include, for example, CMIP simulations, large ensemble simulations, or so-called really like twin Earth or digital Earth experiments. I should also mention that we have various containerized versions of the model also available, and they are very useful for tutorial purposes. Students or early career scientists can easily use the CESM through these containerized CSM versions. And it is not an easy task to support the community. So we spent quite a bit of time making sure that the community has access to our documentations and our tutorials, our our code base. I should then mention that all of our code base is freely available. We are not necessarily performing any official releases anymore. All of the CSM code is available through GitHub. And we are trying to make sure that people know where those models are and how they can easily configure them. So these are all available. Another aspect that I should mention, we are also providing guidance as to, for example, how to name the file names, how to store data, how to distribute data that are created by the CSM code base. We also have a discussion forum, and this is quite important because this is inclusive of all the component models or applications of CSM, and people can post their questions or comments on this website. It is monitored quite frequently, and sometimes actual users can help another user to answer certain questions. And finally, I just wanted to make sure that we have multiple mailing lists just to make sure that we have a really fast and easy communication mechanism with the entire community. Each working group has their own mailing list. We also have mailing lists for the broader CSM community. We also make sure that, probably you may have heard of that, we also, for example, advertise community-related sort of efforts, workshop announcements, not necessarily related to CSM, but related to climate modeling. We also provide announcements for various job opportunities. Just to wrap up, a few additional points. I think, as I try to convey here, in addition to making sure that community has a say at the table, and I'm trying to stress that it's a two-way interaction, we need to make sure that also our model is good enough and it has the capabilities that the community needs so that they can directly use our model for their research purposes. So this is quite important. We also are involved with joint proposals or projects with the community members. So when such proposals are written, there's for example, PI or co-PI from NCAR. And if there is some model development aspect of that, usually National Science Foundation provides us some funding to make sure that that university's project is being accomplished. So I think it's what I'm trying to convey here is that even though we are NCAR scientists, we are also there to serve the community and meet their needs. Another aspect that I just wanted to mention is that we have some awards that we give out: Distinguished Achievement Award and Graduate Student Award. These are, especially the Graduate Student Awards, are extremely useful to encourage community engagement at early career scientist level. And we think that this is quite important. These awards are quite important to recognize communities, particularly at the graduate student level, contributions to the CESM. And finally, I just wanted to stress that diversity is a key element also. I'm not just talking about gender balance in our working groups here or advisory committee membership or steering committee membership, but more in general, we are also trying to reach out to minority serving institutions and underrepresented groups and those universities which serve those groups. We are trying to essentially make a concerted effort to be all inclusive in our community engagement. And with that, I'll stop and take any questions that you may have. I can stop sharing my screen so I can see better. You are muted, Andy.
Thank you, Gokhan. Okay, so we have time for some questions. I guess if there's questions on the Zoom chat, Gokhan can monitor that. Any questions in the room? Just wait for the microphone because obviously Gokhan can't hear you. And maybe introduce yourself while you talk.
Yeah, hi, I'm Dietmar from Monash University, and I have a question, maybe a two-part question. I wonder how big is the model developing team in terms of 100% stuff? And I wonder when
well, yeah.
my second part of the question. So when you develop a next generation covered model, how much is this a community effort or how much is it due to the core team sitting at NCAR?
Those are all good questions. So we have the ocean model. Ocean model team has about 3 to 4 people. Actually, it's probably more than that because we have in our section we have about 10 people who can contribute to model development. But in terms of actual FTEs, we have about 2 to 3 for ocean modeling. Atmospheric modeling group has about, again, 10 to 15 members. They all contribute, but the actual FTE amount, I would say 6 to 7, perhaps internally. Land ice has about 2 to 3. Sea ice internally has 1 to 1.5. That's a consortium. We use the sea ice model, 5 and 6. And the land model is also a relatively big group. I would say, even though they have about maybe 10 plus people, in actual FTE terms, that would probably translate into maybe 3 to 5. That would be my guess. Software engineering aspect, our team has about 4.5 to 5 base funded software engineers. From the community side, it is quite a bit of community effort because just to give you an example, in the United States, we have so-called climate process teams. They involve university people and us, for example, and also GFDL is involved in those efforts. Certain implementations of parameterizations, such as ocean mesoscale mixing parameterization or vertical mixing parameterization, they're all developed in conjunction, in collaboration with the community. So those efforts come every 5 years or so, and they involve quite a bit of community involvement. They can have up to 4 or 5 postdocs, early career scientists contributing. Land modeling group in particular has quite a bit of external projects. They directly contribute to the development of the land model. So it is, even though I would say most of the core development occurs at NCAR, a significant fraction actually occurs at the universities and other national centers as well.
Okay, thanks. Next question is from Aidan.
Hi. This may sound a bit rude, but I'm just wondering, is there any sort of standout failure that you encountered, and what did you learn from that going forward?
Yeah, I mean, there are quite a lot of failures, of course, too. For example, we need to make sure that there is a two-way buy-in. In other words, we may be interested in NCAR in a particular parameterization, but if we cannot really efficiently collaborate with the external person, for example, who developed that parameterization, then that doesn't necessarily go too far. And there have been some examples of that. We, for example, implemented some parameterizations in the ocean component, and they didn't work out as advertised. They were essentially agreed upon, and the community thought that they were good efforts to try, but sometimes we don't really get much out of it after spending so much time on it. So those happened before. Another thing in these cases usually underestimated in terms of effort is, I'm not saying this in a negative way. It is usually easy to incorporate a parameterization in a component model. However, making sure that it works nicely with the other component models. It is tuned well, and it is essentially producing a reasonable climate model or climate simulation. That is the part that takes so much time. Even, I mean, model tuning exercise, I guess, with all of these developments is an important part that is primarily done by us at NCAR. And that requires quite a bit of knowledge of the model and, I guess, experience. And that's the part that community lacks. And our contributions in these community projects primarily essentially targets that area as well.
Okay, we have, I think, one final question from Chloe.
Hi, I'm Chloe from CSIRO. I was interested, you mentioned diversity in, I guess, kind of the staff, also the community. I was wondering how you go about ensuring that you have diversity.
Well, that has been extremely challenging. So what we are doing right now, what we learned over, especially over the past 2-3 years, is that sending out just blanket emails to minority serving institutions or underrepresented groups is not simply working. It doesn't work. What we are trying to do is establish personal connections. So if for example, an NCAR person knows somebody at those universities, then we try to directly contact those early career scientists. We try to directly contact their professors and establish connection through that way. We found that personal engagement, and it is really difficult, it is really time consuming, but that is the way to actually get people interested in using CESM. Another challenge is that, unfortunately, in the United States at least, most of the minority serving institutions or underrepresented groups do not have a climate sort of effort. They don't necessarily offer climate-related courses. So we are thinking about actually going to those universities once this pandemic thing is hopefully over and engaging them directly, and then maybe try to get connections and maybe try to get sort of interest in those entities towards climate science. But that's going to be probably more challenging.
And Julie had one more question. While you're getting the microphone to her, can I just ask, would you say those direct interventions have been successful? I mean, what's your success rate in those interventions?
I can't give you a percentage, but we tried it over the last 2 years for our tutorials to get early career scientists from those institutions. From 1 or 2, so of the order of maybe 80 folks, from 2 or 3, we went up to 9. So I can give you that number essentially. In the past, we had maybe 1 or 2 people out of 80. So we are now of the order of 9 or 10, let's say, out of 80. So that, I think, is relatively successful.
Okay, Julie, and this is the very last question.
Thanks, Andy. Hi, Gokhan, Julie Blaster. Good to see you.
Hi.
You've mentioned at the start that there's the kind of component model working groups and then these application working groups like the climate variability and change working group.
Yeah.
So you just touch on how they are mutually kind of beneficial to each other and how they might be working together.
Well, that's a good question. Modeling groups tend to essentially be in their own world, and they're trying to make sure that certain things work, and then they produce a reasonable climate. But the modeling application groups, such as the Climate Variability and Change Working Group, analyzes model solutions in detail, and they document the variability, and they actually help us identify model shortcomings, like representation of answer, representation of A and B, and that goes back to the modeling development groups, and we try to address those to the extent possible. But some of them are, of course, challenging. Another recent example is the equilibrium climate sensitivity, right? CESM is one of the models with large equilibrium climate sensitivity. And as I showed last week in my State of the CSM presentation, our paleoclimate working group spent quite a lot of time trying to figure out why that was happening, because when they run the model, for example, with the high equilibrium climate sensitivity for paleo applications for last glacial maximum, they end up with a really cold surface temperature, and that's no good. They can't use the model for that purpose. So they ended up spending order 1.5 to 2 years. They actually tracked down an issue with the mixed phase cloud formation. They suggested relatively simple 2 modifications in the microphysics in CAM, and that actually reduces the equilibrium climate sensitivity of the model. And that was extremely helpful for us. So those application working groups are quite important for us to identify problems, and in this case, perhaps find the solution for the model development team. So it's a two-way interaction.
Okay, thanks. I think we're going to call it there, and maybe you can join me in thanking Gokhan again for his time. And Gokhan, you are, of course, welcome to stay and join in our discussion groups, but you might prefer to go back to your holiday.
I'll do that.
Thank you so much for taking the time to join us.
Thank you. And then if you have any questions, please feel free to send me an email.
Yeah. Okay, thank you.